Hello, everybody. It's Captain Coots, and this is going to be a very special one of my tutorial videos, and hopefully I'll do some more of these. I'm going to call them my whiteboard tutorials for unknown reasons. I don't know why we call them whiteboard videos, but I wanted to go over certain design choices that I make as I go outside of the video where I make them so that I can explain them in kind of longer detail and have visual aids. Okay, and so to pick up, we were making code we were modding the mobile truck base mod, okay, and we were doing some hardcore tracking, okay, and what we can see here is I wrote if hardcore tracking right there, and then we call those things, otherwise just advanced time, and then I used hardcore tracking over here, this entire script, just to do the hardcore tracking bit. You know, we turned it off, we advanced some time, we turned it back on, etc. Right? The way it was written before was this if-else structure basically was not there. What we would do is we would call this, and inside here we did if-else. And I didn't like how that felt. I was like, no, we're going to rewrite it this way, and I'm going to like this better. Okay, and what I wanted to do today was sort of justify that decision I made a little bit with a whiteboard doohickey thingy. Those are good words, right? So I present to you design choices with C.O.O.T.S function calls, all right, where we will be exploring a couple scenarios and seeing why I might have made the decision I made, why you might make that decision, and what the various trade-offs are when you're going to be doing these things. If you're an experienced modder, most of my arguments you're going to either know already or you're going to know better than I do. You might want to skip it. Who knows? But it might be cool, and you can write comments below where you bash what I said, okay? If you're new, this might be good to watch because then it's going to help you sort of make decisions on like, why did we structure it like that? And should I, when I'm writing code, structure things like that, okay? So, the basic premise of the experiment today is I want to think about having two different scripts, script A and script B, done in blue and red right here, okay? Now, in script A, for our first scenario, we're going to put the structure where script A reads, if condition is the same as 1, then call B. Else, do stuff. End. Now, that might not be all the code in A. A might contain a whole bunch of different stuff. And try to imagine that. There's code before this if statement and code after. And maybe do stuff is a whole bunch of lines of code. Maybe it's one or two things. Who knows? Okay. Now, script B, the only thing in script B is whatever do other stuff is. Again, might be lots of lines, might be a single line, but that's sort of the purpose of B. Okay, now under this structure, I want to run a couple of different experiments. My first experiment, let's suppose that the condition is always true. The condition is always the same as 100% of the time. So what's going to happen here? Well, script A is going to get called, and eventually we're going to get to this if statement. And from this if statement, we're going to call B and pass control over to B. And then B is going to do other stuff. So in this case here, 100% of the time the if statement is evaluated, and 100% of the time the script control is passed from one to the other. Cool. All right. New experiment. Let's say 50% of the time condition is true. All right. So then what happens here when A, we eventually get to the condition and we call B. That happens half the time. The other half of the time, when A gets called, push the button, damn it. Yeah, when A gets called, the condition ends up being false. We move to the else statement and we just do stuff. And control from one script to the other was never passed. So 100% of the time the if statement was evaluated, and only 50% of the time script control was passed. All right, if we have this other extreme where the condition is never true, then what happens is when A gets called, this is always false. We always go to else. We always do stuff. We never pass control between the functions. Everything is just in the if statement. Okay, so we have results for this sort of structure. Let's think about a different structure. So in this structure here, and again, there might be code above and below the call B in A. It's not the only thing there. But the only thing in B is the if statement, condition equals 1, do stuff, else, or sorry, do other stuff, else, do stuff, and then end. That's what's in B. Let's run into the same sort of scenario here. Let's say the condition's always true. So eventually, when we're in A, we're going to call B, and then the condition's going to be evaluated to true. We do other stuff. Okay, 100% of the time the if statement's evaluated, 100% of the time the script to control is passed. What about if it's only true half the time? Well, we've got a similar situation here where when we get to call B, it transfers control, and then either the logical statement's true and we do other stuff, or the logical statement's false and we just do stuff. So in either event here, 100% of the time the if statement's evaluated, and 100% of the time script control is passed. If the condition's never true, here's the fun bit, A is still going to pass control over, and 100% of the time we have if statement evaluation, and 100% of the time we have script control passing. Okay, so the results from these two different structures are kind of as follows. In both cases, the logical if statement is always evaluated. In both cases, regardless of whether we put it in A or we put it in B. Now, in the first scenario, where the if statement's in script A, the control passing is limited in nature. It only happens some of the time, depending on how common condition is the same as 1. And in the second scenario, control passing always happens. And I argue that you should write your code so that the process is limited. This control passing thing is always limited in nature. And I have a little bit of a visual. It's not 100% correct, but I want to think of it as a pretty good metaphor for what's going on, okay? So I have script A here in a blue cup, and it's filled about halfway up with water, okay? And then I have script B here, it's a red cup, completely empty. Now, when I'm holding a cup, that means I have that script in memory, and when the water's in the cup, that means certain data is loaded in memory and in that cup. Now, when I'm using the function script, I'm going to be stirring the water. Sounds good? Okay. So if I'm just evaluating A, I'm just stirring the water here. And now I hit if condition is the same as 1. Ooh, I have to call B. So now what I have to do, I have to stop stirring for a second. I got to take some of this information in A, and I got to put it in B. Now, I can't put A down. Because if I put A down, I essentially, in some sense, forget what the hell I was doing and where I was at. So now I got to keep holding A. I got to keep holding B. Oh. And I got to stir this one now to do the stuff I was supposed to do. And now when I'm done, put it back into A, set this down, pick this up, and then go back to what I was doing. Okay? This is why I argue you should probably limit the amount of times that you're passing control from one script to another, especially if you expect to return to the previous one that you were operating in, because of that juggling act. Okay? So you might ask, well, why, instead of having to do the stirring, pouring, instead of calling B, just put everything into A. And that way you could just sit there and just happily stir your code, and there wouldn't be any problems. Well, there are trade-offs, okay? So what we're proposing then would be this sort of situation right here, where we only have one script, and if condition is the same as 1, do other stuff, else do stuff. Now you might be like, great, it's all in one, you're never juggling the cups, everything's hunky-dory. The problem comes in, maybe your code looks like this. If condition is the same as 1, just set a temporary variable to 1. Otherwise, do so much stuff that I purposely made it so that it was big and complicated and it ran off the screen. And it's even worse if do other stuff is also a big chunk of code. We've run into a problem now where you might be parsing through all these lines of code and forgetting that you're even in an if-else statement and what the hell condition was that even put you into the consideration of what am I thinking about, what scenario I'm in. This is a problem of readability. You like your code to be readable, so that way, like, when you come back to your mod project after like 6 months and you haven't worked on it in a while and you're like, what the fuck does this code do? You're able to reread it and get to it. Or like what you've seen what I've been doing right now with the mobile truck base is I'm kind of digging through the code, trying to take it apart and figure out what's going on. The more readable, the easier that is, the more moddable things tend to be. And so when you've got it all just in one script, while it might be nice, your total script load is smaller, your speed is faster because you're never taking time to pick up the other cop, pour data into it, relinquish control from one to the other, do this, stop that, put the data back in, take that out of memory, take control back and reevaluate. You never have to do that stuff. But the problem is you're just going to have a giant chunk of code. Imagine if every single script that was in Fallout 4 was written in a single file. I started to have a panic attack there. It would be terrible, okay? So we don't necessarily want it all in one. We want to pass back and forth. Now, we have another situation of why we might want to have multiple scripts. So here I've got 4 different scripts, A, B, C, and D. And fundamentally, they all do different things. So I might want them to all be in their own different spots. So that way we have readability achieved, okay? And if we just take a look, A has a bunch of code and some more code, and then we do a special thing, followed by some more code. B has blocks of code, and then we do a special thing with more code and then even more code. C has some stupid code, and then we do a special thing, and then with more code. And then D, we do a special thing, and we have more code, and then tons of code. Okay? What's kind of neat here is all 4 of these things do a special thing. Okay? But we've separated them all off so that they're all nice and hunky-dory. We're not doing any function calls, but it might be nice and readable. But here's the problem. Let's say you have a bug report, and you go to debug things, and you find that your mistake is in when you did a special thing. So now you have to edit all 4 instances of do a special thing. You have to do it correctly and not induce any further bugs or mistakes by copy pasting wrong, by typing something wrong. If you type it all out, it just becomes a nightmare. So what I would advocate to do is this is when you make another function. Okay, so I have another script E, and the only thing in E is do a special thing. And then you basically transform your whole code base. So anywhere that they were doing a special thing, they now have call E, where they just reference there. Now, sure, I've made my code base slower, okay, but I've definitely made it more readable in a sense because I've compacted some things and I've taken advantage of something called reusability, okay? So it is often useful to break things up so that way you can have little reusable modular chunks that you can put from place to place, okay? So I guess in the end of the day, we have calling other scripts. Let's just do some pros and cons, okay? A pro to calling other scripts is that you can increase your readability of the individual scripts. Your con, you may need to open up multiple scripts to get a full story of what's going on, and you might just have a whole bunch of things open at once, and it can be kind of obnoxious. A pro, you can take advantage of reusability, which aids in your bug fixing, okay? But a con to that is you have, in fact, decreased the speed of your code. By how much? I don't really know. We don't have some good benchmark testing in any of the Fallout games of how long it takes to call one script to another and how much time it takes to like pass that control. But I hope you enjoyed this first whiteboard talk. I enjoyed doing it, and I hope you learned something. So I'm not going to talk anymore, and I'm going to find the off button. Where the fuck's the off button? I need glasses.